Yo, what's up? Hopefully my stream is good. Yep. Seems okay. So, the concept or uh, this will be a 1 hour stream, um, and I'll just learn segment trees in the stream. That's it. That's all I'm gonna do. So yeah, this is just a disclaimer. I won't be doing any, maybe if there is any lead code question related to segment tree, I'll definitely try and attempt those. But yeah, but first I'll just study segment tree, how to make them, how they work, and how to implement them. That's it. Okay. Okay, let's get on with it. So a segment tree is a data structure that stores information about array intervals as a tree. This allows answering range queries over an array efficiently, while still being flexible enough to allow quick modification of the array. Okay, this includes finding the sum of consecutive array elements left to right, or finding the minimum element in such a range in order of log n time. This includes finding the sum of consecutive array elements a, l to r, or finding the minimum element in such a range uh, in order of log n time. Between answering such queries, the segment tree allows modifying the array by replacing one element, or even changing the elements of a whole subsegment, assigning all elements from a left to right to any other value, or adding a value to all element in the subsegment. In general, a segment tree is a very flexible data structure, and a huge number of problems can be solved with it. Additionally, it is also possible to apply more complex operations and answer more complex queries. See advanced versions of segment trees. In particular, the segment tree can be easily generalized to larger dimensions. For instance, with a two-dimensional segment tree, you can answer some or minimum queries over some subrectangle of a given matrix in only order of log. Uh, how do you pronounce this? How do you pronounce? Is it? This is not log of n squared. This is log squared n. What? I can't copy. What the fuck, brother? Okay. Log squared n. Difference between log n and log squared n. In terms of complexity, which would be faster? My guess would be the first one. Oh, log n. Okay, whole square. Okay. Makes sense. Okay. One important property of segment trees is that they require only a linear amount of memory. The standard segment tree requires 4n vertices for working on an array of size n. Simplest form of a segment tree. To start easy, we consider the simplest form of a segment tree. We want to answer some queries efficiently. What does that mean? I don't know, what we'll see. The formal definition of our task is given an array 0 to n minus 1. Let's just draw these guys. So I've been given an array 0 to n minus 1. The segment tree must be able to find the sum of elements between indices left and right, computing the sum from left to right, a of I. Okay, and also handle changing values of the elements in the array. Perform assignments of the form ai equals x. The segment tree should be able to process both queries in order of log and time. Okay, this is an improvement over the simpler approaches. Uh, A naive array implementation just using a simple array can update elements in order of 1, but requires order of n to compute each sum query. Makes sense. And pre-computed prefix sum can compute sum queries in order of 1, but updating an array element requires order of n changes to the prefix sums. Structure of the segment tree. We can take a divide and conquer approach when it comes to array segments. We compute and store the sum of the elements of the whole array, the sum of the segments 0 to n minus 1. We then split the array into two halves, the left half and the right half, and compute the sum of each half and store them. Each of these two halves in turn are split in half, and so on until all segments reach size 1. Okay, we can view these segments as forming a binary tree. The root of this tree is the segment 0 to n minus 1, and each vertex except leaf vertices has exactly 2 child vertices. This is why तनिष्क जैन, आपने DSA कहाँ से पढ़ी? Okay, so main DSA मैंने पढ़ी भाई. There's a YouTube channel called William Fissett. So this guy has many playlists on each concept. So yeah, when I was a beginner, absolute beginner, I just watched these videos, and they're pretty good. I basically skipped on some of these obscure data structure like AVL. I didn't do AVL. I didn't do network flow. I didn't do bridges and articulation points. I didn't watch this Fenwick tree. But all of the basics like stacks, queues, trees, graphs, and all of the standard algorithms, I studied from this playlist. I'll just paste this link right in this chat. DSA को पैटर्न वाइज करें या टॉपिक वाइज? पैटर्न वाइज करें या टॉपिक वाइज? अगर आप बिल्कुल बिगिनर हो, इफ़ यू आर अ एब्सोल्यूट बिगिनर, देन डू इट टॉपिक वाइज बिकॉज यू नीड टू लर्न दोज बेसिक्स फर्स्ट. पैटर्न वाइज करेंगे तो यूल गेट, पैटर्न वाइज थोड़ा मतलब टॉपिक के ऊपर, मतलब एब्स्ट्रैक्शन है थोड़ा. टॉपिक वाइज यू हैव टू नो लाइक हाउ स्टैक वर्क्स, क्यू कैसे काम करता है, ग्राफ ट्री कैसे चलते हैं, DFS BFS कैसे होती है, डाइक्स्ट्रास कैसे होती है. सो बेसिक यू नीड टू नो. When you know all of the basics and you are pretty familiar with all of the algorithms, basically आप कोई भी basic algorithm 5 मिनट में लिख सकते हो. 5 मिनट भी नहीं, उससे भी कम. मतलब you get very familiar with those basics, then you go to patterns, because those patterns use some elements of those basics. Maybe एक data structure और एक algorithm मिला के एक pattern हो गया, इस टाइप से. So pattern is a higher level abstraction. So depends. If you are a beginner, then do topic wise. If you know all of the basics, then do pattern wise. That's it. और एक बढ़िया चैनल है leetcode. So if you are solving leetcode questions and if you want to look up a proper video explanation with pictures and diagrams, this channel is pretty good for that. Like, yep, that's the two things. DSA करने में कितना टाइम लगता है? करंटली मैं ट्रीज पर हूँ भाई. डिपेंड्स, कितनी जल्दी आप समझ पा रहे हो. डिपेंड्स ऑन पर्सन टू पर्सन. कोई जो एलीट लेवल के प्रोग्रामर्स, जिनका दिमाग कुछ ज़्यादा ही तेज़ चलता है, वो 3 महीने में कर लेते हैं बढ़िया, बिल्कुल 0 to 100. बट जैसे कि मेरा दिमाग, आई एम वेरी स्लो at understanding and grasping concepts. So I've been doing this for years, man. लेकिन मैं फिर भी अटकता हूँ, तो या इट डिपेंड्स. I am basically dumb. That's the key point here. So yeah, depends on your intelligence and consistency. That's it. अब मैं ये बेसिकली वो वाले डेटा स्ट्रक्चर्स और एल्गोरिदम्स कर रहा हूँ जो मैंने छोड़ दिए थे, क्योंकि ये बहुत कम पूछते हैं बट स्टिल पूछते हैं. सो सीपी स्टार्ट करने का बेस्ट टाइम कौन सा है, मतलब कितने टॉपिक्स के बाद करूँ. सीपी आप अभी भी कर सकते हो. सीपी में आई डोंट थिंक यू नीड मैनी कॉन्सेप्ट्स. मोस्टली मैथमेटिक्स आनी चाहिए प्रॉपर, मतलब बेसिक मैथमेटिक्स. और सीपी के लिए कोई कॉन्सेप्ट नहीं चाहिए. जैसे कोड शेफ या कोड फोर्सेस पे 2 डिविजन्स होते हैं, राइट. देयर इज़ अ लोअर डिवीजन, हायर. तो लोअर डिवीजन के क्वेश्चंस आई डोंट थिंक एनी, आई मीन कुछ ज़्यादा कॉम्प्लेक्स कॉन्सेप्ट यूज़ करते हैं. सो इफ़ यू नो जस्ट अरेज and some algorithms on these arrays, you can start CP. I haven't done CP very much, so I can't say, but yeah, मतलब CP में ज़्यादा कुछ चाहिए नहीं सीखने के लिए. You learn along the way in CP. That's the point. And basically ऐसा नहीं होता कि ये करेंगे पहले फिर ये करेंगे. You can just start doing leetcode or CP. You can learn concepts along the way. ऐसा नहीं कि पहले playlists देखनी है, फिर हम टाइम कॉम्प्लेक्सिटी पता करेंगे, इनकी कैलकुलेट करेंगे, then we start doing leetcode. No, you can just do leetcode and learn along the way. कोई क्वेश्चन फंस गया जिसमें नई चीज़ आ गई तो वो कॉन्सेप्ट पढ़ लो पहले, फिर वो क्वेश्चन कर लो. सिंपल. ओके, लेट्स गेट बैक हियर. तो we are okay, segment 3 में डिवाइड एंड कॉन्कर हो रहा है बेसिकली. सो वी आर डिवाइडिंग दिस. पहले तो इस सब का सम निकाल लिया. लेट्स से दिस इज s फ्रॉम 0 to n-1. तो देन वी डिवाइड दिस. लेट्स से n-1 is 8 और 10, राइट. 0 से 10 तक का ही कह रहे हैं हमारे पास. तो द रूट नोड विल बी sum from 0 to 10, sum of elements from 0 to 10. Then left child will be sum of elements from 0 to 5. Right child will be sum of elements from 6 to 10. And we do this divide and conquer until we reach a point where there is only one element from s of 0 to 0. Right. इस सेगमेंट ट्री की हाइट आई बिलीव log of 10 होनी चाहिए, राइट. क्योंकि वी आर डिवाइडिंग एवरी टाइम बाय हाफ. सो यप. आपकी लीड कोड प्रोफाइल दिखा सकते हो क्या? हियर यू गो ब्रदर. दिस इज़ माई लीड कोड. मैं सोच रहा हूँ कॉन्टेस्ट देने चालू कर दूँ, क्योंकि भाई इट्स अ गुड प्रैक्टिस. मतलब अननोन क्वेश्चंस की प्रैक्टिस सही होती है कॉन्टेस्ट से. सो अगला कॉन्टेस्ट कब है? फोर डेज 3 days. सैटरडे 8 PM है और संडे 8 AM है. संडे को नहीं उठा जाता यार सुबह. दैट्स द एक्सक्यूज. ओके, आई कैन ट्राई. इसको कैलेंडर में ऐड करना पड़ेगा यार. इसको मैं ऑफलाइन कर लूँगा. और लेट मी जस्ट ओपन अप अ न्यू विंडो. इसको हम सैटरडे वाले को ऐड टू कैलेंडर. 8 PM to 9:30 July 5. Save. Cool. Okay, back to segment trees. Okay. Segment tree must be able to find the sum of elements between the indices left and right by computing this to this. Okay. And also handle changing values. So if any number gets changed here, so we can just simply update that thing and yeah, update our segment tree. So structure. Compute the sum of each half and store them. Each of these two halves in turn are split in half. So on until all segments reach size 1. We can view these segments as forming a binary tree. The root of this tree is the segment this, and each vertex except leaf vertices has exactly 2 child vertices. This is why the data structure is called segment tree, even though in most implementations the tree is not constructed explicitly. Okay, see implementation. ये नीचे आएगा ना इसके, right? Okay, आएगा. Okay, no worries. Here is a visual representation of such a segment tree over the array 1, 3, minus 2, 8, minus 7. Sarthak Jain, are you currently employed? Yes, I am. Yup. Here is a visual representation. Okay, 1, 3, minus 2, 8, minus 7 is given. So total sum will be 1 plus 3, 4, minus 2, 2, 10, minus 7 is 3. Okay, 3. Then from 0 to 2 we have sum 2, 0, 1, 2, 3, 4. Makes sense. Then we divide that into half again. Okay, makes sense. From this short description of the data structure, we can already conclude that a segment tree only requires a linear number of vertices. The first level of the tree contains a single node, the second level will contain 2 vertices, and the third it will be 4 until the number of vertices reaches n. Until the number of vertices reaches n. Correct. Thus, the number of vertices in the worst case can be estimated by 1 plus 2 plus 4 plus 2 log base 2n. That is correct. So, which is log base 2n plus 1. 4n. Okay. It is worth noting that whenever n is not a power of 2, not all levels of the segment tree will be completely filled. Correct. Makes sense. We can see that behavior in the image. For now, we can forget about this fact, but it will become important later during the implementation. The height of the segment tree is order of log n, because when going down from the root to the leaves, the size of the segments decreases approximately by half. What is your role at your company? I am software engineer 2 currently. So yeah, that's my role. I write code. Wait a second. Yeah, I'll be back right now. I don't know what this is. Okay, this is just a smudge. I thought my screen cracked, my monitor screen, but there is no worries. It's fine. Okay. Yeah, I'm software engineer 2 currently. Yep. It is worth So what is your current location? Current location is Bengaluru, but I work from home. It is a remote job, so yeah, I just work from home in Gurgaon, in Delhi NCR. The height of the segment tree is order of log n, which makes sense. I can write these facts somewhere, man. So, height of segment tree is equals order of log n. Correct. Makes sense. Construction. Before constructing the segment tree, great, I also work at startup in Gurgaon. Whoa, nice. Which startup? Before constructing this segment tree, we need to decide the value that gets stored at each node of the segment tree. For example, in a sum segment tree, a node would store the sum of elements in its range left to right. The merge operation that merges two siblings in a segment tree, for example, in a sum segment tree, the two nodes corresponding to the ranges L1 R1 and L2 R2 would be merged into a node corresponding to the range L1 R2 by adding the values of two nodes. It is a health oriented startup. That's great, man. Great. So, do you go to the office, or is it work from home or hybrid? How is the work culture? So, what this stream is all about? This stream, so today I'll just read segment tree. What are segment trees? How to create one? What is the retrieval and insertion in this? How to do that? What is the time complexity? I'll just write an implementation in C++ from scratch and maybe do some questions. So this stream will cover all of these things, most likely. Yeah, that's all. Okay. The merge operation that merges two siblings in a segment tree. So basically, if we are given two ranges, then if we add the sum, we get the range L1 and R2. Okay. Note that a vertex is a leaf vertex if its corresponding segment covers only one value in the original array. It is present at the lowermost level of a segment tree. Its value would be equal to the corresponding element A of I. Makes sense. Now for construction of the segment tree, we start at the bottom level, the leaf vertices, and assign them their respective values. On the basis of these values, we can compute the values of the previous level using the merge function. And on the basis of those, we can compute the values of the previous and repeat the procedure until we reach the root vertex. It is convenient to describe this operation recursively in the other direction, from the root vertex to the leaf vertices. The construction procedure, if called on a leaf vertex, does the following. Recursively construct the values of the two child vertices, merge the computed values of these children. Makes sense. We start the construction at the root vertex, and hence we are able to compute the entire segment tree. The time complexity of this construction is order of n because we have to go through each element in that array. Yeah, I had to go to office 5 days a week. Oh, that's brutal, man. I'm just looking to switch company but confused. How should I prepare for interviews and how should I apply? So, if you are a software engineer, then just grind LeetCode and system design, and then apply anywhere, man. Apply anywhere you see a job post. LinkedIn, company portals, other job portals like Indeed or Naukri or InstaHire. There are a bunch of these, and maybe you can ask for referrals on LinkedIn. Just connect to a bunch of people, just spam messages that I need a referral, please help me, I need a I along with in the message you also paste the job link that you want to apply for. So yeah, basically it's like cold calling. So if you know, like cold calling, people just call you, people just call the salesman calls a bunch of people expecting a sale to close. Like he just tries and tries and tries, and if he succeeds in one or two, that's great, right? So it's all about, yeah, spamming. Just spam. There is no other way. Or if you have elite network, you know the best of the best people in the company, then you can get referrals very easily, or you can get direct interviews very easily. So yeah, it's a balance between networking and spamming. So yeah, yeah, that's my 2 cents here. Yeah, I am SD1 in my company. Yeah, okay. Yeah, it's that's the same strategy I followed to switch companies. Just spam and network and ask people for referral. That's the point. It does get boring sometimes. You can't do that every day. Just converted my internship to full time last month. Should I look for new company? Well, it depends. If you want more money, then sure, look for a new company. If you're happy with your job, if you're happy with your money, if you're happy with what you do, if you're happy with your project, and you enjoy and you are learning new stuff every day, then I don't think you need to look for a new job. But if you are unsatisfied with any of those, yeah, just switch company. But also, I mean, it depends what you want in your new job. Do you want job satisfaction, or just money will do the deed? If it is just money, then you should look for uh, different startup pay a lot, but the culture is just garbage. The managers treat you like trash, and you are expected to meet unrealistic deadlines. So yeah, depends what you need in life. Like, I want to work in a MNC, and how large scale product works. Okay, so yeah, just prepare lead code and apply. That's the key point. So if you okay, currently I see that you are in a startup, so it is way different. MNCs are way different than startups. MNCs have a particular way of working, while startups are just get this shit to work, right? In MNCs, there's sorry. In MNCs, there is a process to everything. Vipul, hi brother, I have placements in 1 month. I haven't secured any internship. Should I add some fake experience in resume? As people with some experience, they give some more preference. So confused regarding that. Um, well, it it's your this is a decision that you have to take. Like I can't add anything here. But yeah, many companies can catch fake experiences in your resume, like fake stuff. If you put too much fake stuff in there, yeah, they're gonna catch eventually. But if you can sell that, then I think it's okay. I don't know. Well, it's on your own discretion. There's no, uh, don't consider my advice as anything. So it's just in your on your own discretion. I won't take any responsibility for any repercussions. That I want to declare. Which company are you working in? I work at Akamai Technologies. So it's a CDN provider. It's a competitor to Cloudflare, if you have heard of that. Do you bother that your colleague also knows that you live stream? I don't know if any of my colleagues even know that I have a YouTube channel, so I really don't care, honestly. Just wanted to know your views on that. Bro, I never added fake experience in my resume and I never would. But I can do some like embellishments in there. So, yeah, it depends. Like, you have to sell your resume, right? So, you have to modify it in some way. But fake experience is outrageous, in my opinion, if you're asking my view. I know that it is hard for new graduates to find a job this in this season, so yeah, it's hard, but it's not impossible. That's my view. Yep. Okay. So I was on construction of this segment tree. Okay. So we are recursively building the segment tree from root to the leaf nodes, which is easy enough. Some queries. For now, we are going to answer some queries. As an input, we receive two integers left and right. We have to compute the sum of the segment A left to right in log n time. To do this, we will traverse the segment tree and use the pre-computed sums of the segments. Okay. Let's assume that we are currently at the vertex that covers the segment TLTR. There are three possible cases. The easiest case is when the segment ALR is equal to the corresponding segment of the current vertex. Okay. We basically find the perfect match of the given query to our segment in our tree. Then we are finished and can return the pre-computed sum that is stored in the vertex. Alternatively, the segment of the query that can fall completely into the domain of either the left or the right child. Recall that the left child covers the segment ATL to TM and the right vertex covers the segment TM plus 1 to TR, with TM equals TL plus TR by 2. Okay, it makes sense. In this case, we can simply go to the child vertex, which corresponding segment covers the query segment, and execute the algorithm describes here with that vertex. Aman, okay. Hey, I would be going for my master's this year in a top ranking B school. I wanted to work abroad for 2 years and come back after master's. Is there a good demand for someone who has abroad work experience? Uh, well, I don't think I'm qualified to answer this question, but I mean, there is always demand for good people. I mean, competent uh, human beings. There is always a good demand for those. So if you are good, you'll be good, man. There will be always a job for you if you are good enough. Also, brother, regarding projects in the interview round, if one is having basic projects, not that hi-fi projects, are they bad to keep? Like, I have implementation based projects, HTML, CSS, JavaScript, bit of React. So if you know everything in that project, like if you have created that project from scratch, you understand all of CSS that you have used, JavaScript, and all of the React things that you have used, and you can explain them to the interviewer, then you're fine. Like, you should know your stuff. That's the point. Yeah, people do write their hi-fi projects, but they struggle to sell those. I mean, they struggle to explain what they did, so it's better to keep basic projects and have all of the explanation. Like, yeah, you should be aware of your project. That's what I want to say. But I mean, yeah, it also depends on like hmm yeah, this is a good question. I mean, it also depends on your project also. I mean, if it is just plain front end application with no back end integration, it's just a visual artifact. But yeah, if you are applying for a front end position, then it's fine. But if you are applying for a back end or a full stack position, then you must have a back end in your project. So yeah, really depends on the level of your project. And yeah. Okay. So I was on this. Alternatively, the segment of the query can fall completely into the domain of either the left or the right child. Recall that the left child covers the segment TL to TM and the right vertex covers the segment TM plus 1 to TR. In this case, we can simply go to the child vertex, which corresponding segment covers the query segment, and execute the algorithm described here with that vertex. And then there is the last case, the query segment intersects with both children. In this case, we have no other option as to make the two recursive calls, one for each child. First, we go to the left child, compute a partial answer for this vertex, the sum of values of the intersection between the segment of the query and the segment of the right child. And okay, this is way too much text. Let's take a look at some examples. In other words, since the left child represents the segment team, whenever the boundaries of the current query coincide with the boundaries of the segment, in that case, the answer will be the pre-computed value of the sum of the segment which is stored in the tree. Okay, Parth Joshi is here. I'm in BCA third year and I want to go in AI ML. I can get job after graduation. Well, if you know AI ML, then definitely you can apply for those roles. And yeah, if you're good enough, you can get the job. What I don't know what I mean. And there are many positions for AI and ML, so you have a pretty good shot. If you're good enough, you can do it, man. It doesn't depend if you're in BCA or BTech or, well, some companies care, but most companies do not. So I think you'll be good, man. If you know your stuff, then you'll be good to go. Yep. Okay. So I was looking for some examples to run through. Brother, any sources for OOPS like theoretical stuff I'm able to get, but regarding those coding questions of OOPS, can you tell any source? Coding questions of OOPS, can you tell any source? Object oriented programming, right? Let's see. So, I do have a page. I mean, I have a website here. Let's see if I have OOPS concepts. I have design patterns. I don't know if you want to study these right now. Depends on how much experience do you have. But yeah, it's good to know these stuff. This contains design patterns which are used in OOPS or object oriented languages. So there are a bunch of patterns, mainly divided into three categories. But this is still high level. If you're struggling with basics of OOPS, then yeah, just Google and Chat GPT, man. You can use Chat GPT. It'll be good enough, I believe, for the basics and even for design patterns. There is another website for design patterns. I think it is called Refactoring Guru or something. Yeah, Refactoring Guru. Yeah, this is good. This has some real life examples also. So if you click on design patterns, this is good. Design pattern is related to system design. Well, it is also related to object oriented programming. This is low level design. So low level design is all about keeping your code in a good uh, position. Oh, was that your question? Oh, yeah, it's related to both. I mean, you can use some of these patterns on a high level also at a low level, but usually on the code level you'll be using these. So system design, when we talk generally about system design, it means handling servers and stuff. We are not getting into code when we talk about system design generally, but there is low level design. There is a thing called low level design which deals with how you design your code and your project structure and stuff like that. So for that we need design patterns. I'll just paste these two links. I'm learning system design for interviews, which is good, man. Good. Should I refer your design patterns? So these design patterns are for low level design. So yeah, you can refer if you want to learn these. But yeah, these are like good to know actually. If you know these, you'll be a good engineer overall. Yeah. Jatin Aroda, hello. Need DSA interview tips. What kind of tips? I don't know, brother. What are you struggling with? Sonakshi Vajpayee, this stream got recommended to me. What is this channel about? This channel is about programming mostly, software engineering and stuff like that. Yeah, mainly about that. Currently I'm reading segment trees, so yep, I just need to learn this segment tree data structure. So okay, you are getting this in YouTube recommend list, is it? So maybe the algorithm is working, man. I'm a YouTuber, yes. Are you a student? Nope, I'm not a student. I'm an employee or a software engineer at some company. That doesn't matter. I'm not a student, basically. Yep. Okay. So, I was looking for some examples here. The procedure is illustrated in the following image. Again, the array is this. And here we want to compute the sum 2 to 4. The colored vertices will be visited and we will use pre-computed values of the green vertices. This gives us the result -2 plus 1. What? So if we are trying to find out from 2 to 4, this 0, 1, 2, 3, 4. Yeah, it is -1, but how do we do that? The colored vertices will be visited. I see that 2 is on the left, right? So I'll go to the left, but 4 is on the right. Hmm. 2 to 2, okay, 3 to 4. Oh, okay. Why is the complexity of this algorithm order of log n? To show this complexity, we'll look at each level of the tree. In shorts, can you take In shorts, can you take few DP questions too? In YouTube shorts, you mean? Yeah, I can. I mean, yeah, I can create shorts for DP questions. Yeah, that's a good point. I can write this down. Let me just, yeah, that's, thank you for suggesting. Okay. Okay, so time complexity is order of log n because the height of the tree is log n, and we can, in the worst case, will just reach at the end. We can show that this proposition at most 4 vertices each level is true by induction. At the first level, we only visit one vertex, the root vertex. So here we visit less than 4 vertices. Now let's take a look at an arbitrary level. By induction hypotheses, we visit at most 4 vertices. If we only visit at most 2 vertices, the next level has at most 4 vertices. That is trivial because each vertex can have at most 2 recursive calls. So let's assume that we visit 3 or 4 vertices at the current level. From those vertices, we will analyze the vertices in the middle more carefully. Since the sum query asks for the sum of a continuous subarray, we know that segments corresponding to the visiting. Therefore, we visit at most 4 log n vertices in total. That is equal to a running time of order of log n. In conclusion, the query works by dividing the input segment into several subsegments for which all the sums are already pre-computed and stored in the tree, and we stop partitioning whenever the query segment coincides with the vertex segment. Then we need order of log n such segments. Okay. Now we want to modify a specific element in the array. Let's say we want to do the assignment ai equals x, and we have to rebuild the segment tree such that it corresponds to the new modified array. This query is easier than the sum query. Each level of segment tree forms a partition of the array. Therefore, an element ai only contributes to one segment from each level. Yeah, makes sense. I currently learning Excel, SQL, and Power BI to get internship for data analyst or any other type jobs. Is this right way of entering in CS? I'm little confused. Uh, hmm. So, are you trying to do data analysis, or are you trying to build AI models that analyze data for you? I mean, if you answer that question, then the path will be different for these two choices. If you want to become data analyst and analyze using Excel or these things, but if you want to create AI models, I think you need to do a bit more than that. So if you learn Python, that would be the most helpful because Python is used everywhere in machine learning and AI. So yeah, I will recommend learn Python, learn ML libraries of Python, and yeah, that's the entry point for AI jobs. Okay, so update queries. If I change the value of ith element in array to x, and then we have to rebuild the segment tree. This query is easier. Okay. It is easy to see that the update request can be implemented using a recursive function. The function gets past the current tree vertex and it recursively calls itself with one of the two child vertices, the one that contains AI in its segment. Makes sense? And after that recomputes its sum value, similar how it's done in the build method. Again, here is a visualization using the same array. Here we perform the update a2 equals 3. The green vertices are the vertices that we visit and update. So 2 is in the left vertex, so we change the sum here, change the sum here. Okay. Update is done, query is kind of done. I'm not exactly sure how the query works, but yeah, I can go to the implementation. Maybe I'll just learn there. Okay. So for implementation, the main consideration is how to store the segment tree. Of course, we can define a vertex struct and create objects that store the boundaries of the segment, its sum, and additionally also pointers to its child vertices. However, this requires storing a lot of redundant information in the form of pointers. We will use a simple trick to make this a lot more efficient by using an implicit data structure, only storing the sums in an array. A similar method is used for binary heaps. The sum of the root vertex at index the sum of the root vertex at index 1, the sums of its two child vertices at indices 2 and 3, the sums of children of those two vertices 4 to 7, and so on. With one indexing, conveniently the left child of a vertex at index I is stored at 2i and the right one is stored at 2i plus 1. Equivalently, the parent of a vertex at index I is stored at I by 2. This simplifies the implementation a lot. We don't need to store the structure of the tree in memory. It is defined implicitly. Makes sense? Just like a heap. We only need one array which contains the sum of all segments. As noted before, we need to store at most 4n vertices. It might be less, but for convenience, we always allocate an array of size 4n. There will be some elements in the sum array that will not correspond to any vertices in the actual tree. Yeah, but this doesn't complicate the implementation. So we store the segment tree simply as an array of t with a size of 4 times the input size n. So we have n and t is 4 times max n. The procedure for constructing the segment tree from the given array A looks like this. It is a recursive function with the parameters A, input array, V, the index of the current vertex, and the boundaries T, L, and TR of the current segment. In the main program, this function will be called with the parameters of the root vertex, T, L, and TR. Makes sense? So in build, we have A, which are the values, V, T, L, and TR. V is the current one. So initially it will be 0 or 1 since we are storing the root at 1. Makes sense? So TL is 0, TR is n minus 1. If TL is equals TR, then T of V will be A of T of L. Makes sense. Else, then we get the middle element. We call recursively on the left subtree, which is from TL to TM. Then we call on the right subtree, which is V times 2 plus 1. Yup, TM plus 1 to TR. Then we say TV equals TV times 2 plus TV times 2 plus 1. Makes sense. Easy. Further, the function for answering sum queries is also a recursive function which receives as parameters information about the current vertex segment, the index V and the boundaries TL and TR, and also the information about the boundaries of the query L and R. In order to simplify the code, this function always does 2 recursive calls. even if only one is necessary. In that case, the superfluous recursive call will have L greater than R, and this can be easily be caught using an additional check at the beginning of the function. If L is greater than R, then it is invalid range, then return 0. If L is equals TL and R equals TR, then return that value at TV. Then we get the middle element, which middle element of the given query? No, the range. Okay. If L is equals TL and R equals TR. So I'm passing in sum of V2. I'm going to the left subtree, from the left original 0 to the middle L, the query L, and minimum of R or TM. How does this work? Let's create the graph here for this array, which is 1 3 minus 2 8 minus 7. Okay, this will be 1 3 minus 2 8 minus 7. That's it, we don't need this shit. 0 1 2 3 4. In market, data related jobs higher or AI ML related? I don't know, bro. But yeah, I have seen a shortage of AI ML engineers and an abundance of data analysts. So yeah, you can see what I'm going with here. So there are less AI ML engineers and there are more data analysts. So if you are trying to become a data analyst, so it's a tough competition. But if you know AI ML, and yeah, there are many jobs. Even, I mean, Microsoft has changed some of their software engineer titles to AI engineer or something like that. Let's see if I'm correct with this. Microsoft software engineer jobs. Yeah, I mean, I have seen some of the jobs being renamed to AI software engineer or something like that. So yeah, there are jobs for AI. Okay, back onto here. So let's create a segment tree for this. So the segment tree will create will be the root tree. I mean, the root node will be the sum of all elements, which is Actually, I already have one here, so I'll just copy this guy and paste it here. This is my segment tree. Okay. Now let's take that code of query, this code. Let me just take a screenshot, paste it right here. Now, initially, v will be 1, right? Because we are starting at 1. Okay, let's write here. We have v, we have t, l, t, r, the query, which is l and r. V is 1, TL is 0, TR is 4. Let's say I am querying on 1, 2, 3. And then what's gonna happen here? If L is greater than R, nope, return 0, so this won't happen. If L is equals TL and R is equals TR, which is not the case, so this won't happen, then we are getting the middle point of these two, which will be 2. Then I am calling sum on V 2 times V, which will be so basically this is calling 2, and TL will be the left, which is still 0. TM we calculated it as 2, and minimum of right or TM. Makes sense. Minimum of right or TM. L will be same and right will be 2 here. And another recursive call, 2 plus 1, 3. This will be 3, and TR is still 3, right? I mean, sorry. TR is what? TR is 4. Sorry. Yeah, TR remains 4. Max of L or TM plus 1. So L was initially 1. Max of 1 and 3 is 3. And right remains the same. Now, okay, 3, 4, 3, 3. Now, okay, now in this case here, L is greater than R, nope. L is equals TL, nope. Then we get the middle again. Now this will be 1. Then I'm trying to find the sum from 0 to 1. And left will be 1 again, and minimum will be minimum of right 2 or TM, which is 1. Okay. Now that will give me this sum, right? 3. 3 will be returned. Then I'll sum this with TM plus 1, which is 1 to 2. This will be 2. TR is still 2. Max of L or TM plus 1. This will be 2. Okay, this will give me minus 2 here. Then I'll add them up. Then I'll return here, which was this. Yeah, it makes sense. You did BCA or BTech? I did BTech in computer science from a college in IP University. So not a great college. It was a tier 3 college. So yeah, that was my journey. But I do work with people who did BCA currently. So yeah, it's fine, man. Okay. If I really want to understand this recursive relation, so I am splitting TL and TR, which is original range, from TL to TM, from left to minimum of right or TM, because that is my capped right. And then on the right subtree, I'm going from middle plus 1 to TR, and I'm moving. I've capped my left element here, left range, so I'll just max this or this. Makes sense. Makes sense. Yeah. Yeah. If I do this on notebook, I'll understand this better. But yeah, I get the point. I get the point. When both of them are equal, like when I get the exact range, TL equals L and TR equals R, then I return that value. TB. Makes sense. Makes sense. Makes sense. Okay, I'm getting the hang of this segment tree, man. So this has been a good read. I will cover update function tomorrow, because I just understood the construction and how to build and how to get the sum query. The update, I'll cover update tomorrow in my tomorrow's stream, most likely. And we can look at more efficient implementations here, memory efficient, advanced versions. Yeah, I'll just complete this page basically. Okay, so I'll stop the stream right here. Thank you for joining. Thank you for all the questions. If you felt that I helped you in some way, you can subscribe. Or if you don't want to subscribe, that's fine. I don't. Yeah, it's fine, man. But yeah, anyways, I'll see you guys tomorrow. And until then, GG's, have a good night.